Good afternoon, ladies and gentlemen. Welcome to Math 10C, Chapter 5, Lesson 2, Properties of Functions. Now, last class, we talked about functions and how to write them out. Talked about arrow diagrams and tables and ordered pairs and all that, or technical terms representing relations. So here's a couple of them here. This on the right, red one is an arrow diagram, is the number of players on a team 4. 5 on basketball, 6 on hockey and volleyball, 9 for baseball, and 11 for soccer. And on the right is a table of value, masses of different numbers of Canadian quarters. 1 quarter is 4.4 grams, 2 quarters is 8.8, 3 is 13.2, and so on. Now, newish for you guys, definitions that you should end up putting on your blue sheets. Domain is a set of first elements of a relation, and range is the set of related second elements of a relation. Now, domain is, we usually just call that our x values, and our range are our y values. So, x is the first thing we talk about, and y is the second, and note it's related to the first. So, this is x, this is y, color code, oh you poopy head, stop that. People are watching. This is x, this is y. Now, so far so good? All right. Now, if you watch some videos on this, sometimes they will call this L1 list 1, and they'll call this L2 list 2. Now, I'm just mentioning that now because some people like going on videos in Khan Academy and the others, which are quite good, talk about this. Now, list 1 and list 2 is in your calculator, and I will show you how to put those lists in to do calculations and draw graphs, but not now. Just be aware they exist. So, why is it doing that? Okay, anyway, sorry about that. Now, here we go. The number is the number of players on a team 4, 5, 6, 9, 11, baseball, basketball, hockey, soccer, volleyball. So, typical question for this arrow diagram, what's the domain? Well, the domain is 5, 6, 9, and 11. That is our x values. Now, the range, or our y values, are what? Baseball, basketball, hockey, soccer, and volleyball. Note, the domain or the range don't have to be numbers, they can be things. Now, that's one little thing. The more important and the last thing or the second most important thing I want to talk about is this a function? Now, a function is a special type of relation where each element in the domain is associated with exactly one element in the range. Now, that's a definition you're supposed to know, definition of a function. The easy way to remember that is the range can repeat, but the domain can't. So, how should I put this? I've never found one definition that's not real wordy. Every x has one and only one y value. So we go up here. Does each x have one and only one y value? Well, 5 has only one y value, but 6 has two y values. It could be hockey or it could be volleyball. So no, this is not a function. Okay? Now, as I said, take a minute at the end here. Actually, pause the recording now. Come up with a definition that you like for function. Special type of relation where each element in the domain, your x, is associated with exactly one element in the range, y, or the range can repeat but the domain can't, or every x is one and only one y value. Come up with your own definition. If you have to Google it or search it in the internet, well, welcome to my world. Anyway, pause the recording, come up with that, and then when you're done, come back and we'll talk some more. So pause the recording. Okay, moving on. A few more example questions. A relation that associates 5 foods to the food groups to which they belong. Orange is a fruit, cheese is dairy, broccoli is vegetable, milk is dairy, and kiwi is fruit. So what's the domain here? The domain, or our x values, are orange, cheese, broccoli, milk, and kiwi. Now, that's the domain. Notice once again, no numbers. What's the range? Fruit, dairy, veg, vegetable, dairy again, and fruit again. So, is this a function? Every x has one and only one y value, so orange on fruit, cheese, and dairy, yes. So this is a function. Okay? Now, in here the musical instrument is in the key of something. So what's the domain here? Alto sax, clarinet, French horn, piano, trombone. And the range? Is that B sharp or B flat? One of you musical people email me and tell me. I believe that's B sharp, C, E sharp, and F. So, domain and range. Now, is this relation a function? For every x, is there one and only one y value? Yes, remember this is x, this is y. Yes, for every x, there's one arrow going from it, so yes, this is a function. Okay, for every x, there's one and only one y value. Okay, now, describing functions. This table shows sample costs for a pay-as-you-go cell phone plan. So we have the first column is always x, the second column is y. So here, oh, a couple more definitions for you, my bad. Independent variable, that is x. What are you choosing? Number of minutes. What is my dependent variable? That is what depends on my number of minutes. Cost. Now, what's my domain? Number of minutes. So, is it 10, 20, 30, 40, 50? Well, this is a sample. Is it all the numbers? No. So I'm just going to leave the domain as minutes. I don't know how many they are. I'm being rather vague here, and I apologize. What's my range? Sorry, domain is my x values. My range is my y values, which is cost. Now, someone here might say, but Mr. Sutton, we have this written out. So if you say the cost is 2 or 4 or 6 or 8 or 10, I really can't argue with you because you're not listening to me. But that means our domain, our x values are 10 or 20 or 30 or 40 or 50. Now here's the problem. Do you always talk for exactly 10 minutes on the phone? No. Anyway, so is this a function? Is this relation a function? That is, for every x, there's one and only one y value? Yes. This is a function. Now, Carmen works for a research company in a shopping mall. The equation P equals 5n plus 30 represents her daily pay, P dollars, when she conducts n surveys. Now, here, if we want to write this in function notation, our equation is P equals 5n plus 30. Now, to put that in function notation, we'd say P of n is equal to 5n plus 30. And we write that as P of n equals 5n plus 30. Now, this is function notation. The last little thing I want to talk about today. It's not a big thing, but this is a lovely cheating shortcut. And why is it a cheating shortcut? Well, let me show you. Find the value of p of 8. Well, what's p of 8? Well, that's 5 times 8 plus 30. 5 times 8 is 86, 40. Is 70. Now, why is this a lovely cheating shortcut? How else? So if I want to put p of 8 into words, find the value of p when n equals 8. Now, those of you who've been to my class know my spelling. Which do you think is easier for me to say? P of 8 or find the value of p when n equals 8? Which is easier? Yes, p of 8. So that's function notation. Is it a big deal? Well, we're going to do this a lot. So function notation, well, let me give you a couple examples here. Y equals minus 3x plus 5. That's a typical equation I'd ask you to solve. Now putting that in function notation, well, it's function of x equals minus 3x plus 5. Now I went function of x. Does it have to be f of x? No. But f is function, and that reminds me, function notation. Can I make it p of x? Certainly. Minus 3x plus 5. Q of x, r of x, 11d of x? Sure, whatever. Same idea here. I call this p of x. Sorry, p of x, forgive me. P equals 2s plus 15. P of s is 2s plus 15. And yes, if you don't want to call it p, call it f for function. You have the pen, write in whatever variable you want. I don't care as long as you need enough I can read it. Now, if I gave you the equation here in two variables as function notation, d of t equals 4t minus 7, and I asked you to rewrite that as an equation, not function notation, this is d equals 4t minus 7. Or, yeah, that'd be easy. Or instead of d, you can go f or g or whatever. Same idea over here. Instead of g of x, that's function notation. But since we're using x, some people will say, can't we use y instead? Sure. I didn't tell you what variables to use. Surprise me. Okay? Now, let me show you another, well, let's do another example of function notation. Patty lifts weights at the local gym. The equation m equals 5n plus 2.5 represents the mass lifted m kilograms when the number of 5 kilogram masses on the bar is n. Describe the function using function notation. Well, the mass she lifts depends on the number of 5 kilogram masses. It's 5n plus 2.5. So there's function notation. Capital M, m of n. If you're onto f of n, I don't care. So, but notice I said m of 6. So, m of 6. What is the total mass when she uses 6 of these 5 kilogram masses? Or m of 6? A lot easier to find out. Or, sorry, a lot easier for me to say. Now, 5 times 6 is 30 plus 2.5, so that's 32.5. Now, I want to be a poo head. Find the value of n when m of n is 42.5. Okay, well, m of n equals 5n plus 2.5 equals 42.5. So, 5n plus 2.5 equals 42.5. Solve for n. Oh. How do you get n all by itself? Remember BEDMAS. The easiest thing to do is, if you're adding 2.5, subtract 2.5 from both sides. So 5n. Now 42.5 minus 2.5 is 40. So 5n is 40. How do you get rid of times 5? Yes, divide both sides by 5. So n equals 8. So here, Patty is using 8 of those 5 kilogram weights to lift 42.5 kilograms. Strong lady, good for her. Anyway, that's how you solve function notation equation. You've done this sort of thing before. Now, that's it for me. Go do your check your, if you're having trouble with this, watch the video again. Go do the check your understanding questions, and if you're having problems, shoot me an email, otherwise I'll see you in class. Have fun. Good luck.